always complaining about something.
I said it's good.
Okay. Well then, you said it's very bright. You should have said, wow, it's so bright. I love it. Right, part 2, the sequel.
I don't know it.
Return of the electric field strength formula. Right, where did we stop? The examples, isn't it?
When the next midterm break is gonna come, then we're gonna have exam.
Really don't know. I don't think that far ahead. Okay, can you write this question down? We'll have a look. We have 2 examples just to look at before we start the maths. You could draw it as well if you like.
204 volts.
PG.
Potential difference.
Yeah. But that is supposed to be small.
No, I see it like this sometimes.
Huh?
I see capital P,
Yeah.
small t.
Do you really?
Yeah.
Show me. Prove it.
And we don't have any special like outside book or something.
I do actually, but not here.
Ah yeah, how convenient. Fine. I think you're just making this up. I think you just make things up sometimes. I think so. Alright, have you drawn it or written it down? Okay, let's draw it anyways. So it's situation is you have one plate which is a positive charge, and then another plate which is negative. I think it's this way around. Yeah, as a centimeter. This distance here is 1 centimeter. And the voltage as well is 200 volts. And you have a particle here of charge 100 E. Now, is it a positive or a negative charge? It's positive charge.
Why?
Well, because I didn't put a minus in front. So it's plus 100 E. So will the field push it up or push it down?
Push it down.
Push it down. So there's 2 forces acting here. What are the 2 forces acting here?
Electric and the weight.
The electric and the weight. So the total downward force is the force due to the field plus the force due to gravity, which will be QE plus mg. Oh yeah, what did I say the mass was? I think I said it's half a milligram. So if I go to the side for a moment, 0.5 milligrams equals 0.5 millikilograms over kilo. Just put a kilo above and below. Dude, your prayer reminder's distracting me. That's what it is, isn't it?
Yeah.
Yeah. Right, so you have 0.5 times 10 to the minus 3 all over 10 to the 3 kilogram. So that is 0.5 times 10 to the minus 6 kilogram. Or if you want, you could write that as 5 times 10. So if I make this bigger, I have to make this smaller. Kilograms.
Okay.
So now we go back to our calculation. We have the mass.
10 seconds.
10 seconds it is.
5.
No, come on. Give him a break. He's not Barry Allen.
Done.
Done? So the Q is 100E. Now, what's the formula to get the electric field strength?
1 over.
V over D.
Oh, yeah.
Oh, that thing. And then the mass is 5 times 10 to the minus 7 times 9.81. So I need my calculator now. Put in some more numbers. So the E, what is it? Shift 7.
1.6.
Yeah.
10 to the power minus 19.
1.602
Yes.
times 10 to the minus 19. What's the voltage?
200 volts.
200. And the distance?
0.1 meter.
0.01.
0.
Yeah. Plus 5 times 10 to the minus 7 times 9.81. So let's hit all that out.
You multiplied 100 to E, right?
Yeah, I said it was 100 E, didn't I?
I'm
Yeah.
just asking the actual value of E.
Oh yeah, that's it right there, the 1.6. Oh, I'm missing the 100.
Yes.
Okay, let's give that another go. 1.602 times 10 to the power of minus 19 times 200 times 100 divided by 0.01. Now I think 100 is actually too small because this number is tiny, so I'm going to... Yeah, can you change the question a tiny bit? Instead of saying 10E, say 10 to the 10E. Yeah, 100 is way too small. There's not enough charge on it. So all you have to do is change that to 10 to the 10, and this one here, 10 to the 10. Okay, let's calculate that again. 10 to the 10 times 200 times 1.602 times 10 to the power of minus 19 divided by 0.01. Okay, that's better. Plus 5 times 10 to the power of minus 7 times 9.81. Right, so that will be 3.6945 times 10 to the minus 5 as the force. But I don't think I asked you for the force. I asked you how long until it falls down. So I need to know the acceleration. Newton tells me the acceleration is ma. Sorry, the force is. Now, what did we say the m was? 5 times 10 to the minus 7. So I can get the A now. The A is a big 73.89 meters per second squared. So now I have U, V, A, T, S. The U is 0, the S is 0.01, the A is 73.89. And I want the T, so what formula should I use? S equals? S equals UT plus a half A T squared. So I now can get the T.
But you don't know what's V.
No, but I don't need to know it.
You don't know.
0.016 seconds, or if you want, that's 16 milliseconds. Got that? Yep. Yep.
16 milliseconds.
Yeah.
No, 20.
Hmm?
27.
What? That might be retype this.
You go to power by the lot here, right?
Hmm?
a lot.
Yeah. So this sounds like some.
Got this?
Yeah.
No.
What they're waiting for.
Somebody solution equals on the
Yeah, sure are. Done for. Right, electron is 2 millimeters from 3 protons. What is the force felt by the electron? Okay, write that down, please. Or draw it.
and the
Electron is
Okay, you got that? Yeah. Okay. 3 protons and an electron. Proton, 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 electron. The distance here, 2 millimeters. What's the charge here?
3 times
Positive 3e. And the charge here? Minus an e. So if we use the other formula, we can get the... which way is the field? Inwards or outwards?
inwards. Outward.
Correct. So the field is going out here. So how strong is the field at this location? Well, what's the formula? It's the... No, the other one. 1 over 4 pi epsilon 0. So that's just a constant. Times Q over R squared. So if I type all those numbers in on the calculator, let's see, 1 over 4, 1 over 4 pi epsilon 0 times, and the charge, now what's the charge here? Is it E or 3E?
3e.
3E, good.
Why?
Because what's providing the field? What's providing the field? The 3 protons, yeah. Over the distance, which is 2 millimeters squared. So when I type this in on my calculator...
Did you type 2? Just 2?
Huh? What?
You changed the meters.
I changed the millimeters to meters, yeah.
Okay.
I get 1.08 times 10 to the minus 3 newtons per coulomb.
This was just only plates we have, right?
Huh? Say again?
These formulas for when we have plates.
No, the other formula is when we have plates. This one's when we have a point. Yeah.
But you want to find force.
Oh yeah. Not finished yet. Yeah. So we also have the formula that E equals F over Q. So that means F equals EQ. Now, we have the E, but what do we use for the Q? Is it the E or the 3E? The 3E.
So we use 3.
For the other part, yeah. So if I just multiply my answer by E, I get my answer for the force, which is 1.73 times 10 to the minus 22 newtons. Is that what I want, the force?
Why didn't you use the 3?
The formula here, this Q is the charge of the thing that's moving. So this is the thing that's moving. And this one here is the charge of what's making the field. Okay. Let me draw. Give me that.
Newton.
Yes, 1 Newton of force. Okay, you got that?
Just a minute.
Okay. Yeah?
Okay. Always the electron move and the proton is like
No, it's which one is, well,
depends on the question.
yeah, well, electrons are a lot smaller than protons. So the proton is going to make the electron move. You know this from chemistry, the electron must go around the proton.
Yeah.
You never have it the other way. So usually the electron is the thing that's moving.
Yeah.
Yeah.
Most likely.
Most likely, but not always. If you had enough electrons, you could have a proton orbiting the electrons. It'd be kind of difficult to do, I would have thought. Okay, we got this?
Yeah.
Yeah.
Math?
Yeah, but let me just put up your homework.
What is not time to do homework?
Funny, you don't have time to do homework or your physics graphs. So what are you doing with your time, apart from Netflix?
Lab reports.
Incomplete lab reports, you mean?
It was complete with diagrams.
Not the physics one.
Hmm.
The lab journal. Had it.
Oh.
Oh.
Even no diagrams?
What?
I think you had your diagrams, just no graphs.
In what?
Physics journal.
No, just no graphs, just no graphs. Did everything.
Except what I asked you to do. Yeah. Okay.
Just a minute.
Yeah.
Few seconds.
Got it?
Yeah.
The first
The video gets uploaded after the class, so you could always just go to the end of the video and pause it, and you have the questions on the screen. You know. You're all subscribed, aren't you? Do you get notice when there's new videos?
No.
Oh, I thought you did. Can you opt?
No, you can if you go to the options.
Okay, well there you go. Okay. What? Whatever. Let's go on to maths now. So that was electric field formula, strength.